Hi everyone, and welcome to our lesson on impulse. This lesson follows on from our momentum lessons. And in this lesson we're going to be learning about how an impulse acts to change the velocity of an object. An impulse is basically a force acting over a time. You can see that in the formula there. So if we have a force acting to the right here, we'll say it's 3 newtons. And that force acts over 7 seconds. So 1, 2, 3, 4, 5, 6, 7. We can say that there was an impulse applied to that object of the force times the time. So time equals 7. The impulse is equal to 3 times 7, or 21. Now the units for impulse are newton seconds. Since force has units newtons and time has units seconds, you can just write the two units together like that, ns, newton seconds, newtons times seconds. Here is the really important thing about impulses. F times t is equal to the impulse, and the impulse is equal to the change in momentum of an object. So to demonstrate why this is useful, I'm going to solve this question first of all the difficult way, and then we'll solve it the easy way. I want to figure out the final velocity of this box. Let's work out the acceleration first. So F is equal to ma. F over m is equal to a. 3 over 5 is equal to 0.6. That's the acceleration. The box accelerates for 7 seconds, and v equals u plus at. If it starts from rest, then the final velocity is equal to 0.6 times 7, or that's 4.2, I think 4.2. Yep, 4.2 meters per second. So this would be the longer way of solving it. Let's solve it the short way. The starting momentum is 0, and there is some final momentum at the end. The change in momentum is equal to 21, because that's the impulse, 3 times 7. So change in momentum is equal to 21, which is also equal to the final momentum, since it starts at 0. And that final momentum is equal to mass times velocity. So 21 over the mass, which is 5, is equal to 4.2. So instead of going to our Newton's second law, F equals ma, we can just use the impulse to figure out the final momentum, and from that we can figure out the velocity. I find there are fewer mistakes made with this method here. Let's look at an impulse applied to a sailboat. So we have the ocean there, the sailboat here, and we'll say that there is a force of 2,000 newtons applied in that direction for a time of 10 seconds. 3 things we want to figure out. What is the impulse? If starting from rest, what is the final velocity? And if starting, excuse me, from 3 meters a second worth of speed, what is the final velocity? And we'll say this boat has mass 5,000 kilograms. 5,000. So the first of these 3 questions is the easiest. What is the impulse? The impulse is equal to the force multiplied by the time. That's 2,000 newtons times 10 seconds, or 20,000 Newton seconds. So the impulse of the wind on the sailboat is equal to 20,000. Since that's the only force acting on this sailboat, the impulse is also going to equal to the change in momentum. So if it's starting from rest, the initial momentum, let's call it Pi, is equal to 0, and the final momentum is equal to 0 plus the change in momentum, which is equal to 20,000 kilograms times meters per second. That is made up of the mass of the sailboat multiplied by the mystery velocity. So 20,000 divided by the mass is equal to the velocity. That's 20,000 divided by 5,000, or that's going to be 4 meters per second. That's the final velocity if it did start at 0 meters per second. Now let's figure out if it started at 3 meters per second, 4 meters per second, what is the final velocity? Well, if it started from 3 meters per second, the initial momentum is equal to the mass of the sailboat times that velocity, or 15,000 kilograms times meters per second. And the final momentum is equal to that starting momentum plus the change. And the change has not changed. The change in momentum has not differed from that result we found before. So plus 20,000, 15,000 plus 20,000 comes to 35,000. That's the final momentum of the sailboat, which is equal to the mass of the sailboat, 5,000, times the velocity. So 35,000 divided by 5,000 gives V by itself 7 meters per second. Now there's one more thing I'd like to show when it comes to impulses, and that's what happens when you have two impulses acting on an object. Let's say all the while that sailboat was experiencing the impulse of the wind on itself of 2,000 newtons for 10 seconds. There was a force being applied on the boat by the water of 1,500 newtons. If it starts from rest, now let's figure out the final velocity. Well, the impulse of the wind on the sail hasn't changed. It's still 20,000 to the right, so positive 20,000. Now the impulse of the water on the boat is equal to the force, which is actually negative 1,500 multiplied by the time we're looking at, so times 10, or negative 15,000. So we have a positive impulse and a negative impulse, because impulse is a vector. We can have negative values. So the sum of those impulses, net I, is equal to 20,000 plus negative 15,000. It's 20,000, take away 15,000, or 5,000 Newton seconds. And we can use this to figure out the change in momentum. So what I should really say up here isn't that the impulse is equal to delta P, it's that the impulse is equal to F times T, but that the net impulse is equal to delta P. So if the delta change in momentum is equal to 5,000, and it does start from rest, it means the final momentum is also equal to 5,000 kilograms times meters per second, which is equal to the mass of the sailboat times the velocity. 5,000 divided by 5,000 gives V by itself. Final velocity, 1 meter per second. We'll look at, in the next impulse lesson, graphs of force times time and how you can work out impulse from that.